Look at this city, millions of lights, endless motion, every window glowing. Electricity is the invisible heartbeat of modern life. Now imagine it vanishes. Not a shortage, not a blackout on one street, everything. 1 second it's bright and the next the world goes silent. Streetlights die, traffic signals blink out, cars roll to confused stops as intersections turn into chaos, phones show no bars, then no signal at all, elevators freeze between floors. In hospitals, alarms spike, then backup generators roar to life, powering only the bare minimum. Somewhere, a data hall goes dark. Inside the digital world, the collapse is immediate. Routers fail, cell towers go quiet, payment systems stop mid-transaction, refrigerators warm, water pumps slow. A countdown begins in the mind of every city. How long until food, clean water, and order run out? So what if electricity disappeared for 24 hours? To understand what we'd lose, we have to rewind. Far past power plants and smartphones, to the first time humans noticed a strange force. In the ancient world, people rubbed amber with fur and watched tiny bits of straw jump like they were alive. Static electricity was a mystery, observed, not controlled. Centuries later, curiosity turned into experiments. In the 1700s, Benjamin Franklin chased storms, suspecting lightning and electricity were the same. Sparks leapt, theories grew, and the world began to see electricity not as magic, but as a natural phenomenon with rules. Rules we could learn, measure, and someday harness. Then came breakthroughs that changed everything. Alessandro Volta built the first practical battery, stacking metals to create steady current. Michael Faraday discovered electromagnetic induction, move a magnet through a coil, and electricity appears. And Nikola Tesla pushed alternating current and motor technology, shaping the grid that powers cities today. Faraday's idea is the heart of modern generation. Motion becomes current. So where does that motion come from? Step into a power plant, steel steam, and deafening force. The logic is simple. Energy becomes mechanical rotation, rotation turns a generator, and the generator produces electricity that can travel and do work. Crack open the generator in your mind. Inside, copper coils sit beside powerful magnets. As the rotor spins, magnetic fields sweep past the coils and push electrons into motion, an electric current. It's elegant and relentless. Whether the turbine is driven by steam, falling water, or hot gas, the generator speaks the same language. Different power plants simply feed that rotation in different ways. Coal and natural gas burn fuel to make heat, turning water into steam. Hydroelectric dams use gravity and rushing water. Nuclear plants use fission to create heat without combustion. Wind turbines borrow motion from the sky itself. Same goal, spin the shaft. Solar is the exception that proves the rule. Photons strike silicon cells and free electrons directly, no spinning turbine required. But solar power rises and falls with the sun, and wind arrives on nature's schedule. That's why modern electricity isn't just about generation. It's about balancing supply and demand every second. Once electricity is made, the journey to your home begins. At the plant, transformers raise voltage, so power can travel long distances with less loss. High voltage lines stride across landscapes like metal giants. Substations route the flow, and local transformers step voltage back down, quietly preparing it for everyday life. Finally, it reaches your neighborhood, then your walls. A single switch becomes light, an outlet becomes communication, cooling, cooking, and motion. Chargers refill phones, refrigerators preserve food, computers open entire worlds. An EV drinks power overnight and wakes ready to drive. Electricity doesn't just run devices, it expands human capability. Now remove it again. Servers shut down and the internet dissolves into silence. Traffic lights fail and roads clog. Water treatment plants struggle. Fuel stations can't pump. Factories halt mid-process. Supermarkets lose refrigeration. Hospitals ration backup power. Without electricity, the crisis isn't darkness. It's the collapse of systems we forget exist. Transportation shows how fast the world is changing. We went from horses to gasoline, then hybrids, and now electric vehicles driven by motors with instant torque. Batteries pack energy into heavy, silent bricks. Electric trains cut city air pollution. Drones and prototype aircraft hint at electrified flight. Next comes autonomy, electric and self-driving. Look forward and the demand explodes. AI data centers drink electricity to train models and serve billions of requests. Cities add heat pumps, EV charging, and electrified industry. The grid becomes smarter, sensors, software, and rapid control. but reliability now depends on storage, next-generation batteries, pumped hydro, and maybe green hydrogen.